Hello everyone. In this video, we are going to talk about the formula for sine of a plus b. These are typically called compound formulae or addition formulae for sine of a plus b. And we are also going to discuss the formula for cos, the cosine of a plus b, as also the tangent of a plus b. There are a couple of ways of doing this. The way we are going to discuss is a nifty way that uses complex numbers. That might already be somewhat alarming and scary, but all that we need is to remember this one formula. Remember de Moivre's formula. So what is de Moivre's formula really? It says that I take an angle theta. So de Moivre's formula essentially talks about an angle theta and says that e to the power I will tell in a moment what I is. Theta is equal to the cosine of theta plus I times the sine of theta. So what are the facts about complex numbers that we need to remember? That I, where I is equal to the square root of -1. It's a complex number. So we understand that for complex numbers, so cos theta plus I sine theta is a complex number where the real part is cosine of theta and the imaginary part, the one after the I, is sine theta. Okay? And this is the formula we are going to use. So as one can guess, what we are going to do is we are going to substitute theta is equal to A, theta is equal to B, and see what happens. Okay? So let's substitute for theta is equal to A, B, etc. Okay? If I place theta is equal to A, then I get e to the power I A is equal to the cos of A plus I times the sine of A. And similarly, exactly similarly, we have a similar expression for e to the power I B is equal to cos of B plus I times sine of B. Okay. Now what we are trying to do is get cos of A plus B. It's already there somewhere. Cos of A plus B, we do know that if I placed theta is equal to A plus B in this formula, then I have e to the power I times A plus B is equal to cos of the cosine of A plus B plus I times sine of A plus B. Okay, so somehow the idea is to jumble up or mix up these expressions, the first two expressions, and get the third one. Okay, how do we do that? Notice clearly we know that e to the power I A plus B is equal to e to the power I A plus e to the power times e to the power I B. And so what does that give us? On the one hand, we have this expression for e to the power I A plus B, and on the other hand, we have the product of these two expressions, the product of cos A plus I sine A and cos of B plus I sine B. So let's write that out. So cos of A plus B plus I sine of A plus B is equal to, let me go over to the next line, is equal to cos A plus I sin A times cos B plus I sin B. And now we need to expand this out. So the expansion is cos A cos B plus I sin A cos B plus I sin B cos A, and there's a fourth term. Let me go over to the plus I squared sin A sin B. Okay, I'm sorry that went over 2 lines, but that's how it looks like. What I'm going to do now is I'm going to collect like terms. Notice that I squared is nothing but minus 1. Because of this, I squared is equal to minus 1. So therefore, I can think of this as minus sin A sin B, and that one does not have. So what I'm going to collect up are like terms. Collecting like terms, I get cos A cosine of A cosine of B minus sine of A sine of B, because of this I squared becoming minus 1, because of this I squared becoming minus 1, just to repeat, and plus I times sine A cos B plus sine B cos A. Okay, and now all that is left to do is, we know that if two complex numbers are equal, their real and imaginary parts separately have to be equal. So that means cos of A plus B has to be equal to cos of A cos of B minus sine of A sine of B. And likewise, the imaginary part I sine of A plus B has to be equal to I times sine of A cos of B plus sine B cos A. Let's just write that out. Therefore, cos of A plus B is nothing but cos A cos B minus sine A sine B, and sine of A plus B is nothing but sine of A cos of B plus sine of B cos of A. Okay, and that's it. So thereby we have, so imagine, just realize how powerful this formula happens to be. From this single formula, which is quite nifty looking, we got in one fell swoop both the formulae for cos of A plus B as well as the sine of A plus B. But wait, we also promised the formulae for tan of A plus B. How do we go about doing that? That's not too far from this actually. So tan of A plus B, the tangent, which is by definition the sine of the angle divided by the cosine of the same angle. And now it's a matter of substituting these expressions, these horrendous expressions. So let me copy these. Okay, that put it there. Sorry, that's the denominator. Is the sine, which is here, divided by the cosine, which is here. Okay, how do we want to simplify this expression now? This expression is, okay, what do we want really? We want the tangent of A plus B in terms of tan of A and tan of B. Tan of A, tan of B are nothing but sine over cos of A and B respectively. And I see that there's a cos A cos B sitting right here and a sine A sine B sitting right here. So what I need to do is I need to divide this by, this by this, by the cosine of A cosine of B. So let's go about doing that, and let me get these terms once again. This is this, and this is once again the denominator, which is cos of a plus b essentially. And now I am going to divide both the numerator and the denominator by what? By this term. Okay, divided by brackets and this term, and thereby what we have is, again let me have a fraction which is of, if you see that the cos b and the cos b cancel and sin a by cos a pops out, and that is nothing but tan a. And similarly the second term gives us tan b. The denominator gives us 1 minus tan a tan b. Beautiful. And that's it. Tan of a plus b is equal to tan a plus tan b by 1 minus tan a tan b. Okay, and that is it. We are done. In the next video, what I am going to concentrate on are getting the corresponding formulas for sine of a minus b, cos of a minus b, and so on. In fact, what I will show is that for all of these formulas, you need to remember just one of the formulas and the rest of them can follow. Okay? And I am also going to give some mnemonics for remembering the formulas, these addition formulae. Okay, thank you. Bye.